Hi, I'm Ben Sharafian. I'm an intern at Ripple, and I'm going to be talking about Ilp Trust Lines, which is what we do when a ledger does not yet support Ilp. So here we've got our ideal scenario. We've got a network of ledgers, they're connected to each other, and we can just send our Ilp payments through them. It kind of looks like this, right? We've got the sender in red. They send across a shared ledger with a connector. This gets routed across more shared ledgers, however many connectors, however many steps they need to get to the receiver. So the problem with this is that Alice needs to be on a shared ledger with some connector in order to send ILP right now, because there aren't a lot of ILP-enabled ledgers. So this is what it's probably going to look like until we get more support. So you got our developer or somebody who wants to use ILP. We call them the noob. And we've got a connector, somebody who has a shared ledger with more connectors on ILP-enabled ledgers, and we call them the nerd. And something needs to go in between them for the noob to be able to send payments. So in the internet, I'm told, I wasn't alive for this, when this sort of thing happened, we used dial-up. Oh, the screen's off. There we go. And that's, using phone lines to send internet connection, because not everybody had an internet connection yet. So the way we emulate this in ILP is we've got Trustlines. And so I've written ILP plugin virtual. Evan was talking about ILP plugins. So this implements the Ledger plugin interface. But the thing about ILP plugin virtual is there's no actual underlying ledger. You don't need an account on some ledger. You just create a connection between a noob and a nerd directly. And you've got some balance on this trust line. And what that means is the nerd extends $15 of balance to the noob. So if the noob sends a payment, that gets deducted from the balance and the payment gets routed through the nerd. So sometimes you don't want to just be charitable and give somebody a balance on a trust line and get nothing in return. So what you can do is you can settle your balance over some service. You could use PayPal or you could use just cash. And what that basically means is, let's say I'm the noob, I hand the nerd, $20. They just increase the balance by 20 for that. And then you can send more payments through. And that's a way that we can get this to work over services that don't yet. Because if I want to send money through PayPal or something, we just settle the balance over PayPal. So I have a demo. This sort of starts from, we've got the wallet, which you've seen before. This has a balance in it right now. It's at $1,005. And we have a Trustline client here, which is not yet connected to anything. So when we want to create a trust line, you authenticate through a token. So right now the token is this thing, and the noob can use that to just connect to a trust line. So I've got this just command line interface to start a trust line. We take our token here, plug it in here, and we have our balance. And it's got a lot of logging that you probably won't understand. I don't understand some of it. And what we can do is we can send payments. We'll send 5 payments. And this gets routed through a connector onto another account on a ledger. What we can see is this balance goes up because it's received those payments. So that can connect just any client you write using trust lines to anything else using ILP. Thank you.
If people have questions about what we just presented in terms of the implementation or the trust lines.
Question from Shane online.
Question from Shane.
Just a private phone. Are there, we talked about having these ledger plugins. Is there a convenient way to
there will be.
So the question was,
Sorry,
is there a
yeah.
test suite for exercising these ledger plugins and validating that they're correct?
Yeah, so that's one of the things on the
You need to mute your microphone as well.
Oh, geez.
Okay.
Or you.
Okay. So having a test suite for ledger plugins is very much one of the things on the to-do list.
It's off. I don't know what's going on. Sorry.
Probably right by the name of the Trustlines.
Just unplug.
In this last demo, you do just trust the connector. If you send him money, he won't.
Yeah, you do have to trust whoever you have a trust line with.
Yeah.
Because there's no ledger in between to separate you.
Yeah, so that's one of the reasons we call that like the dial-up version, where it's not great because you'd rather have this whole nice system where nobody has to trust anybody except their ledger. But as Ben showed, like adoption's not great right now, which we need help with. But you can kind of do that as one way to get on, and it's not that unreasonable. Especially so, Ben's example had a $1,700 balance. That's probably not super likely, but we can do that because it's fake money with the red and blue demos. But if you're doing that for like $10 or £10, 20, something like that, then maybe it's more reasonable that sure, I trust my friend for that much. And we can either do it where it's pre-funded, where I trust the whoever is more connected to the system up front. So I'll just I'll hand you a 20 and then you extend me credit. And I'll come complain to you if you don't actually do it. But you can also do it post-funded afterwards, where if you trust me to pay you back for it up to the amount up to a certain amount, then we can do that as well.
I think it's important to mention like what you get for it, and what you get for it is you're fully on Interledger. So if you wanted to use like Evan's BitTorrent client and pay and receive money to upload and download, if you have a trust line from Ben or anyone that's giving these out, you can't do that. And so you can fully use Interledger. You can send individual micropayments to 10,000 different recipients, and then settle once through PayPal. So we think that could be pretty powerful in terms of like getting this out to a lot of people very, very quickly.
Eventually anyway, right? So someone you trust the whole thing, fiat money for you, right? So
The question is like you have to trust the bank anyway, so it's not that different. So the question is like, you always have to trust somebody to hold a balance with you, and so this is just a way to do it where it's like a little more peer-to-peer, who's like holding the balance. But it's probably better if your bank or a cryptocurrency or whoever like is the issuer of the money that you want is the one that's actually representing that balance, because then like if I have an account with them, I trust I trust that system to do the accounting properly if I have an account with it. So then I'll trust it to facilitate to kind of be my connection with Interledger as well.
There's a question here as well, and I mean the fundamental difference there, right, is you either trusting a connector or a ledger. If you don't have a ledger to trust, then you use this virtual thing to trust a connector instead.
You've mentioned a couple of times that you're concerned or you're excited about adoption and expanding, the exposure of the protocol. Obviously, there's a risk with adoption of one, getting things out in the wild that are not necessarily standard yet, and two, having the standard evolve underneath you as an implementer in a way that might not be backward compatible. So if you're encouraging people to do implementations and make this available, can you talk to the commitment to making sure it still works?
So I think that there's like, by trying to reduce the amount of stuff that we're actually standardizing permanently, basically the packet that you saw on the screen, we're trying to minimize the amount of things that people could disagree over. So just to go through some of the things that we had up on the slide in terms of what's in the packet, the address is a string and it's separated by dots. You could use colons, you could use slashes, but beyond that, I think it's a pretty pretty straightforward way of creating identifiers. We actually borrowed that from a project called Named Data Networking. It involves some of the original creators of TCP/IP, including Wen Jacobson, who now works at Google. And they've spent a lot of time coming up with this identifier scheme, so we feel pretty good about doing something like along those lines, because it's probably already pretty thought out. For the amounts, I think there's one really big controversial question you might ask, which is, are those amounts floating point numbers in binary, or are those decimals, which are basically base 10? And you can go either way. Base 10 has the advantage that you don't get weird rounding errors, so we kind of went that way because we think ultimately the system is for humans still, and so we don't want weird rounding errors when we send human readable amounts around. But those are the kinds of decisions that we have to make, and one of the other categories as well is the crypto conditions. We're actually going to be in Berlin at the IETF meeting presenting the crypto condition spec that we propose in 2 weeks, and so we'll see what the reaction is, and we'll see if there's a lot of debate about it, or if people are largely okay with it. And based on that feedback, we might simplify it further or go with something like this. So those are kind of the things that we're trying to standardize. So we're hoping that we don't have to standardize too much else, especially on that sort of very foundational layer in terms of ILP. Yeah. So that's kind of the answer to that. Okay.
How are these Interledger trust lines different from Ripple trust lines?
Mm-hmm. So I would say, like, financially, they're a very similar concept, right? So it's the idea of if there's another user that is already connected in this network, I can use their liquidity, and that goes all the way back to Ryan Fugger's original vision. And so for us, there's almost like a certain beauty to this very long path over 12 years that this protocol has sort of taken, and it's gone to distributed ledger, and that has added something to it. We could talk about that as well, but and then it's kind of coming full circle back to the roots, like back to being a pure protocol, right? And yeah, we think that there's a certain beauty in that, and we made sure that the specs say that Ryan Fugger really kicked this off, and so we really credit him with a lot of these deeper ideas in here.
For those who don't know what that history is like, do you want
to? Yeah, sure. So I'm actually probably not an expert on it, but I'll try to give you my best, recollection, which is back in 2004, Ryan Fugger came up with this idea to create a global credit network. So basically, the idea was to use trust lines to connect, friends together, and then you would find paths across these trust lines in order to facilitate transactions with people. And I think some of the things that have been added since then was the idea of cryptocurrencies. They can provide very valuable sort of global interconnectivity, because trust lines, I think, work really well locally, because you know your friends that are in your local area, and you know who they are, and it's easier to build trust there. But for international settlement, you might not know the counterparty. They might be in a different country. It might be very hard to enforce contracts and debt on them. And so for this international settlement, we think that cryptocurrencies are great. For the local settlement, probably something like trust lines is better because you can reach into all the existing systems. You don't have to onboard everybody onto cryptocurrency first. And so all of these ideas sort of come together, and they're very complementary. And so I think, that's kind of what we're trying to do with Interledger, just kind of bring it all together.
More questions?
I have a question about what happens if a payment fails somewhere across the various different hops. So we've got a timeout expiration parameter in there, and it could easily happen that we are making 6 hops or 3 hops or whatever, and it, for some reason, hits right in the middle of the timeout in a way that one of the payments is actually made and the next payment fails. How does the protocol facilitate rollback or payment cancellation in that scenario?
Great question. So one thing to emphasize up front is that what the core protocol does is insulate the sender and the receiver from risk. So the sender has no if somebody else fails later down the chain, they have no risk, because the sender is putting money on hold with their ledger, saying, either I will get a cryptographic proof that the recipient got paid or my money back. So that's a very important thing to realize with this, is because like in the current system, if you do a wire transfer, for example, you take a fair amount of risk, because if something like wire transfers happen with a kind of blind handoff where you tell your bank to do a wire transfer, they send it on to the next one, and nobody has any idea what's happening in the process. And so if something fails, I, the sender, am actually out the money, which is...
Do you mind if I relay a quick story in that context? Because we interviewed somebody, and we told him about, 1 to 4% of Swift wires fail. And he's like, I experienced that. I'm like, tell me more. And so he said that he was starting a new company in Singapore, and so he wired some money from London to Singapore. I think it was like £15,000 or something like that. And after a couple of weeks, he was wondering where the money was and why it wasn't arriving. And so he went to his bank, and his bank told him that we can go look into that for you. That's no problem. Don't worry, we'll get your money back. It'll just be 40 quid for us to figure out where your money went. And so it's like a little bit insult to injury in that case. So it's great to have that cryptographic proof whenever you're sending a payment.
Yeah. So the key thing, I just wanted to emphasize that up front. So the failure scenario that you're describing is one in which the connectors stand to lose money. And so if I'm a connector and I'm facilitating a payment, and I set we showed in the flows how the connector is actually paying out before they're getting paid back. So it's important for the connector. One of the ways that we didn't touch on this in the presentation, but the expiry times actually are kind of telescoping. So the sender's transfer has the longest expiry. So if we're sending this way, Stefan might put money on hold for 10 seconds, and the next connector might put their money on hold for 8 seconds, and so on down the line until the recipient maybe has 5 seconds, let's say, to actually sign the receipt. So the recipient signs the receipt. Then I, the connector, have basically like whatever window I've given myself to take that receipt and deliver it as quickly as possible as I can to the next ledger. Now, your question is, what happens if I don't? So that can happen either if let's say one of these ledgers is down or my connection to them is faulty. One of the things to realize is that's a problem that's very kind of under my control. Like I can make my connection as reliable as possible with this ledger. So we can have private connections, we can have multiple redundant connections, because I just need to make sure that I get that notification as quickly as possible. If that ledger is in general kind of faulty, I might ask for more of a buffer, where I say, I can't do this, and I'm not going to take the risk of doing it in 2 seconds. I need 5 full seconds or longer, whatever it is, in order to kind of give myself a reasonable assurance that I'll actually be able to deliver it, even if the ledger is not responding kind of quickly. Now, what happens if, let's just say, I try to do as best as I can to insulate myself, the connector, from risk. I have multiple redundant connections, still fails. I pay out, don't get paid back. So there's 2 ways that we can look at this. One is, let's say this was a relatively small payment. Maybe I just eat the risk, or eat the cost of that. If I'm facilitating 1 billion payments and, some of them fail in this way, that's cost of doing business. I can include that in my rate, and especially I can include that if one of these ledgers is sort of at fault. Most of the time I send through this ledger and this ledger is kind of faulty, or has quirks to it, like maybe something like Bitcoin even. If sending through Bitcoin is kind of unreliable because sometimes it gets in and sometimes it doesn't, then maybe I'm going to ask for a higher fee or something like that to cover my cost. So the connector, it's a very manageable risk, because I can assess what the risk is, what the likelihood is. I can keep metrics on how often this happens to me, and I can, sort of build that into my cost. There's a further thing, which is one of the things that Interledger enables is basically retries for payments. So from the perspective of that scenario that you did, in the wire transfer case, I can't just you can't retry a wire transfer of 15 grand. No way am I sending another 15 grand and hoping that goes through. But what would happen in that scenario that you described is so the recipient has gotten paid. As far as they're concerned, this transaction's done. But the sender never heard anything back. The money just comes back. So as far as the sender's concerned, it hasn't actually happened. And so what the sender can do, because what the sender wanted is They really wanted that cryptographic proof that the recipient got paid, because that's the thing that says, this invoice has been paid or something. So the sender wants that ultimately. So if the sender retries, so they put new money on hold, they're like, I still wanted this payment to happen. Can you please make it happen now? They put money on hold. Some connectors may pass that on. And if it takes the same route that it did before...
And eventually it will have to take the same route, because eventually you'll be at the ledger of the receiver, so you'll have to hit that at some point.
Right. So let's just imagine that it's like we had this broken path, but now the sender's trying it again. And so they put money on hold, and now it gets back to me, the connector who lost money. Now, what I just see an incoming thing is, I just got a held transfer with a condition that I already know the fulfillment for, because I got it before. I heard about what that fulfillment was. So now I don't actually do anything more, because I've already completed my end of the bargain. And so I can just go and fulfill that transfer, and then no money has been lost. So from the sender's perspective, it just looked like the first time failed. Maybe it was a timeout of 10 seconds. Okay, I'll do it again. Try it again. Oh, second time it worked. And second time it took a lot less time, because we only actually did half of the transaction, because the rest of it was already kind of done. So in summary, sorry, that was kind of a long-winded answer to your question, but the connectors in the universal mode of the protocol take the risk, but we can have retries, so the connectors can get paid back, or connectors can build that into their fees.
One thing to add to that is that the ledgers also have a strong incentive to provide that reliability, because connectors will charge more of a spread for ledgers that are unreliable. Ledgers that have high spreads are not going to be as liquid, and so it's not as attractive to connect to them or hold balances on them. So there's this sort of mutual interest. And then one other thing that ledgers can do that helps a lot is if they separate the API that's public, that allows them to create new transactions from the one where connectors post fulfillment. So you could imagine, for instance, that there's a separate IP on a separate network where the sort of most important connectors post fulfillments. And so even if the public API is under DDoS attack or something like that, you might still be able to post your fulfillments to the private API, just not make any new payments, which is fine.
Does that answer the question?
Yes.
Excellent. Do we have a mic?
Yeah, absolutely. So just, again, follow up this time. So is it only the originator of the payment that can retry, or can connectors in a chain retry themselves?
So when a transfer isn't timed out yet, then a connector could, in principle, retry it. Because one way of looking at the whole chain is that each connector is basically like a receiver who then the thing that you've paid for at that receiver is another send, right? So you can kind of think of it as this recursive nesting doll of payments, where you have the ultimate receiver, and then each connector is basically another sender until you get to ultimate sender. So you can do retries as long as the incoming transfer hasn't expired yet. In practice, that'd probably not be very likely, so I think most of the time it'll be the sender that retries.
In the scenario where you have a failed transaction, does the routing protocol allow for that sticky path to go again, to go through the same connector hops to make sure that that connector lost out can retry again? Or is that just look whether the route is still the same the second time?
So that's where you get into some really subtle stuff, which is if I'm a connector, I might want to have that feature just because then other connectors will know that it's more likely that if anything goes wrong, I'll retry through them. And then they might give me a better price they might give to someone else. So they might advertise a cheaper route to me and allow me cheaper payments than someone else. And so I have an incentive to do that, but it's definitely one of the sort of advanced type of features that a connector might support.
Cool. I think, one of the things that's emerging is this really nice, simple protocol, and then the complexity of the connectors is going to evolve over time, and you're going to add more and more dimensions in your decision making for routing, quoting, all of that.
One of the things that I found really interesting when we've been spending a fair amount of time reading the internet specs, basically, because we're finding a lot of parallels with this. And I didn't actually even know that I'm not an internet guru, and I didn't actually know that the routing protocols were updated something like 6 or 7 times since the internet came out. But IP, as far as I'm concerned, the internet is IP. That hasn't changed. There's IPv6, which doesn't have very good adoption, but the core standard that I have to deal with hasn't changed, even though the stuff in the middle and all of these kind of routing details have gotten upgraded a relatively large number of times, completely without me knowing about it.
I mean, and you could realistically end up with networks of connectors who establish ways of sharing, routing, and quoting information between themselves in a completely proprietary way. I mean, it's a kind of a separate thing to the actual payment protocol itself.